of binary code. We're data is the new gold they load. Blockchain freedom lights our way. Digital rights here to stay. Fix our beat, our rhythm true. Personal rights in debut. In the chain we trust and see. Future's bright for you and me.
This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We'll be exploring a fascinating patent application titled Hybrid Human Machine Learning System and Method. This document details a system designed to analyze sentiment in text, combining the power of machine learning with human input. What's the core idea behind this hybrid approach?
The core idea is to leverage the strengths of both machine learning and human judgment. Machine learning excels at processing large volumes of data quickly, but can struggle with nuanced understanding, especially in areas like sentiment analysis, where context and sarcasm are crucial. Humans, on the other hand, are excellent at understanding context and subtleties, but are slower and more expensive to scale. This system aims to combine these strengths for superior accuracy.
So how does the system actually work? Can you walk us through the process?
The system uses a multi-stage process. First, it collects social media posts and other text data. Then, a machine learning model automatically tags this data with initial sentiment and category labels. However, a subset of this data is then sent to human reviewers via a crowdsourcing platform called Tagvana in the patent.
And what do these human reviewers do?
The human reviewers provide more detailed and accurate tagging, including sentiment scores, category assignments, and identification of spam. This human feedback is then used to refine and improve the machine learning model. It's a continuous feedback loop.
That's interesting. How does the system handle the potential for disagreement among human reviewers?
The system uses statistical methods to aggregate the human scores, focusing on measures like median and trimmed mean to reduce the impact of outliers or inconsistent ratings. It also tracks the consistency of individual reviewers, allowing for the identification and potential filtering of unreliable contributors.
The patent mentions different levels of scoring: piece level, item level, and stream level. What's the difference?
Piece level scoring analyzes individual phrases or sentences within a document. Item level scoring aggregates the piece level scores to provide an overall score for the entire document, for example, a tweet or review. Stream level scoring then combines scores from many documents to analyze overall sentiment trends over time.
The patent also describes a sentiment magnitude engine. What does that do?
The sentiment magnitude engine is the core of the automated sentiment analysis. It parses text into pieces, applies rules, some learned, some handcrafted, and assigns sentiment scores. It's designed to be auditable and improvable through the human feedback loop.
The patent mentions mapped sentiment scoring. How does that differ from the magnitude approach?
Mapped sentiment scoring is more sophisticated. It doesn't just sum up individual piece scores. Instead, it considers grammatical relationships and contexts across the entire document to generate a more holistic sentiment assessment. This is more complex, but potentially more accurate.
The system seems quite complex. What are some of the challenges in building and maintaining such a system?
One major challenge is ensuring the quality and consistency of human input. The system needs mechanisms to identify and manage unreliable reviewers. Another challenge is handling the diversity of language and expression found in social media. The system needs to be robust enough to handle sarcasm, slang, and other linguistic complexities.
The patent discusses the use of a rule-based system alongside machine learning. How do these two approaches complement each other?
The rule-based system provides a starting point and a framework for the machine learning model to learn from. The rules can capture basic sentiment patterns, while the machine learning model can adapt and refine these rules based on the human feedback, leading to improved accuracy and coverage.
The patent mentions an adaptive rule learning algorithm. Can you elaborate on that?
This algorithm automatically learns and refines the rules used by the sentiment engine. It uses a modified version of the Whisk algorithm, adapting it to learn rules based on the tagged data from both the machine and human reviewers. This allows the system to continuously improve its accuracy over time.
The patent describes two approaches for expanding the system to new languages. What are they?
The first approach involves manually translating the rule base and lexicon into the new language, then testing and refining the system with data in that language. The second approach uses the adaptive learning algorithm to learn rules directly from tagged data in the new language, requiring less manual effort but potentially more data.
What are some of the key advantages of this hybrid system over purely machine learning or purely human-based approaches?
The hybrid approach offers higher accuracy and better handling of nuanced language than purely machine learning systems. It's also more scalable and cost-effective than purely human-based approaches, as it leverages the speed and efficiency of machine learning for initial processing.
This has been a very informative discussion on this patent application. Thank you.